Okay, we're going to look at section 3.5 and the polygon angle sum theorem. So a polygon is a closed plane figure that is formed by joining three or more coplanar segments at their endpoints. And there's some examples of some polygons and some non-polygons. Each segment is called a side of the polygon. The point at which two sides meet is called a vertex. And a diagonal of a polygon is a segment that joins two non-consecutive vertices. A polygon is convex if each line containing a side contains no points in the interior of the polygon. All diagonals are in the interior of the polygon, and we see that in our figure below. A polygon is concave if at least one line containing a side contains a point in the interior of the polygon, at least one diagonal that contains points in the exterior of the polygon. And you notice in our figure below, the one side points in. So that's why it's concave. Okay, now we're going to look at naming polygons. So if I want to name my vertices, that would be my endpoints. So I have A, B, C, D, and E. So vertices are points. My sides, I have side AB, side BC, side CD, side DE, and side EA. And for angles, we have angle A, angle B, angle C, angle D, and angle E. Looking at our figure on the right, our vertices would be Y, X, W, V, U, T, and Z. And then my sides, we have side YX, XW, WV, VU, UT, TZ, and finally ZY. And then for angles, angle Y, angle X, angle W, angle V, angle U, angle T, angle Z. So notice our vertices, however many vertices the figure has, it also has that many number of angles. Here are some of the names for classifying polygons by the number of sides. You need to be familiar with these. So remember, a triangle has 3 sides, quadrilateral has 4, pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon 9, decagon 10, and dodecagon 12. After 12, we just say an n-gon. It's like a 13th gon, 14th gon, and so on. Now we're going to classify polygons by their sides and identify whether they are convex or concave. So our first figure, it has 12 sides. So remember, that's a dodecagon. And you notice how we have vertices going in towards the center of the figure, such as here, 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 and here. So this would make this concave. Our second one is a decagon, has 10 sides, and it is convex because all our vertices go out. The arrow has 7 sides, so it is a heptagon. And notice we have vertices going in, so it is concave. Our next figure, 4 sides, quadrilateral. And it is convex. And lastly, we have another decagon, and it is concave. The polygon sum theorem says the sum of the measures of the angles of a convex polygon with n sides is n minus 2 times 180 degrees. That will give us the sum of the interior angles of our polygons. The Polygon exterior angle theorem says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. An equilateral polygon is where all sides are congruent. Equal angular polygon have all congruent angles, and a regular polygon, all congruent sides and angles. And here's some examples of each. So we have a hexagon, an equilateral hexagon, equal angular hexagon, and a regular hexagon. Okay, now we're ready to look at some examples where we find missing angles in polygons. Number 1 says a parking lot is in the shape of a hexagon. So there's our key word on our type of polygon. A surveyor measures 5 angles, 56 degrees, 84 degrees, 138 degrees, 165 degrees, and 150 degrees. What is the measure of the missing angle? So the first thing we need to do is find out how many degrees our angles will add up to. So remember, a hexagon has 6 sides, so using our formula, I'll take 6 minus 2 times 180. So we're taking 4 times 180, and we get 720 degrees. So a hexagon's interior angles add up to 720 degrees. To find my missing angle, we can add up the angles we have, plus my missing angle I'm going to call x, and that needs to add up to 720. Combining like terms, I have 593 plus x equals 720. If I subtract 593, I get x is 127 degrees. Let's fix that. 127. Here we go. Number 2 says, find the measure of each interior angle of a regular nonagon. So 2 keywords here. We have regular and we have nonagon. So remember, regular means all the sides and all the angles are congruent, and a nonagon has 9 sides. So again, using our formula, this time 9 minus 2 times 180. And if all the sides are congruent and all the angles, I can just divide that by 9 to get how many degrees each angle is. So simplifying, we have 7 times 180 divided by 9. So 1260 divided by 9, or 140 degrees. In 3, we want to find the measure of each exterior angle of a regular nonagon. So again, same type of figure, but this time we're looking for the exterior angle. And for any convex polygon, the exterior angles add up to 360 degrees. So I'm just going to take 360 divided by 9, and I get 40 degrees. So each exterior angle is 40. Now we are going to look at examples where we are given the picture of our polygon. So in number 4, we have a 4-sided figure, or quadrilateral, and the first thing we need to do is find out how many degrees our interior angles will add up to. So if we take 4 minus 2 times 180, we get 360 degrees. So that tells me my angles need to add up to 360 degrees. So I'm going to write an equation to find my missing angles. Then combine like terms. We have 259 plus s equals 360. Subtract, and we get that s is 101 degrees. All right, looking at number 5. Again, we have a quadrilateral. So from number 4, we know that the interior angles will add up to 360 degrees. So again, let's write an equation showing that the measures of our angles will add up to 360 degrees. And if we combine like terms, we have 2z plus 142 equals 360. We subtract and get 2z equals 218. So that means that Z is 109 degrees. Okay, and number 6. Again, quadrilateral. The interior angles will add up to 360 degrees. So let's write an equation. Okay, combine like terms. We have 2w plus 224 equals 360. If we subtract, 2w equals 136. So that means w is 68 degrees. And finally, number 7. If you notice, we have an 8-sided figure, an octagon. So first we need to find out how many degrees our interior angles will add up to. And we get 1080. Now, all the angles are the same, so we can say 8a equals 1080. Divide by 8. Each angle is 135 degrees. All right, 2 more examples. In number 8, we have a heptagon, has 7 sides. So first, finding the sum of the measures of our interior angles. Take 7 minus 2 times 180, and we get 900. Then add up your interior angles. And set that equal to 900. Combining like terms, we have 3b plus 504 equals 900. Subtract the 504, so 3b equals 396. So that tells us each of the b angles are 132 degrees. And finally, our last example. In number 9, we're looking for the exterior angle here. If you notice by our markings, all the angles and all the sides are congruent, which tells us it is a regular polygon. And if we're looking for the exterior angle, remember exterior angles are going to add up to 360 degrees. So to find x, we can just take 360 and divide by 5. There are 5 sides, 5 interior angles, 5 exterior angles. And we get that x equals 72 degrees.